Guy with the Mohawk, and today we're going to be talking about serialization with cereal. And it's not cereal with a C. It is definitely not any other breakfast foods that you may consume. Instead, it is a serialization module, encoder and decoder that we wrote at booking.com to solve specific problems that we had with everything else. We're going to talk a little bit about what those things are. So first, what does it mean to serialize data? Any volunteers from the audience to give me a definition of serialization? Anybody? Talk to me. What are you doing?
Shove it into a format that you can read.
There you go. See? That's fantastic. Let's see what Wikipedia has to say. Process of translating data structures, yada, 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 yada. So essentially, serialization is basically marshalling data and data structures into a particular format to either store it, to send it across the wire, whatever, and then basically reconstitute it on the other side in a different process, etc. So what is involved in serialization and deserialization? First, you have to understand the data structures in which you're serializing. We know that in Perl you can introspect these data structures very well. Other languages also have this ability to introspect and basically implement like a visitor pattern over data structures to fully understand what exactly it is that you want to serialize. The other aspect of it is understanding the transmission format or the storage format of this data, both so that you can encode it and then some other process or even the same process can then eventually decode it. So when it comes to talking about serialization, it is really about trade-offs. If you can imagine, let's pick on Java and XML for a little bit. When you basically take a data structure, or we could do .NET, whatever, and you decide, I want to turn that into XML. There's a couple of things that you have to be concerned about. One, how fast is that actually going to be? To basically walk your data structure and then actually encode it into the format that you want. XML is a very, very verbose format. You spend a lot of time just writing strings to a buffer. It can make your encoder performance suffer greatly. Next is, what about the decoder performance? So let's say that you put a bunch of time into making your encoder produce something incredibly teeny tiny small. But then it becomes very difficult to then decode that information on the other side. You spend so much time then attempting to decode it that whatever performance you gained encoding it is completely lost. So it kind of defeats the purpose. What about streaming? Like if you want to encode and decode, how do you manage streaming of documents? So prime example, XMPP is a particular protocol that uses XML, which is terrible. And how do you stream XML? Well, you essentially have to batch and wait for a particular top-level node to be finished before you can call that document complete and then send it on its way, even if you're doing SAX parsing, because the entire document is what matters. So there's streaming to consider when you are thinking about an encoder or decoder. Payload size. And oh no, why is it? Any questions? Experiencing some slight technical difficulties here. What are you doing? Why? Why?
It seems like a stuck key or something.
It is like but I have no stuck keys, and you know what it is? It's a Mac. Don't ever buy these. These are terrible, terrible computers.
Try turning it off and on.
I'm going to do that next. Hold on, power button. So talking about trade-offs and streaming and all this other crap, and I'm just going to quit all and try this again. Make this big. So, by the way, it's not cereal with a C. I know. There we go. Payload size. Payload size. That's where I was. If your payload size for your particular object, data structure, whatever, is bigger than what it was when it started out with, then you've essentially failed. And this is why XML fails as a protocol for basically doing any type of serialization. What about Perl data structure oddities? So you can probably, arrays and hashes, and you can represent those in something like XML or like JSON, and you can do it fairly well. But how do you represent like weak references? Because those are very important. What about cyclic data structures? How do you manage those? So these are some of the things that you have to consider when you want to basically do serialization. And then finally, upgrades. Any questions?
Can you hit go back?
I don't know.
Keyword.
So it's about serialization.
It is about serialization, and this fails miserably.
And P doesn't work.
No, P doesn't work. No, it doesn't.
Column R-D-W.
Yeah. Do it the long way.
How many geeks does it take?
I know, right? And of course, this is, you know what? This is Ingy's fault. I blame Ingy. I'm using his software. This is Vroom, by the way. It turns Vim into a slide presenter. And I'll have a nice long chat with Ingy the next time I see him. Okay, so one more time. Let's do a quick all. And I have.
If
You
it
know
fails
what?
This time, just open them all up in regular Vim.
Hey, it kept track of where I was. Somehow. All right, I will try and advance slowly. Upgrades.
Yes.
Don't move. So another problem with doing serialization is managing your upgrades. If you upgrade the module on one side but not the other, then suddenly you have things talking different languages, essentially, or different versions of the language, or even dialects of the same language. So you have to be very cognizant of how you manage your upgrades, and you have to be cognizant of whether your serialization format is actually going to be forward compatible. So that decoders that are older than the encoders can still decode your documents. Now, they may not have all the whiz-bang features, but the core document itself should be able to be deserialized. So when we came up with Serial, we'll talk more about what actual Serial is. We had a number of modules and technologies that we used as prior art for basically teaching us what it means to write a proper serialization, one spec, and then two, an encoder and decoder. Of course, there is the venerable storable. Who here has ever managed a storable upgrade between two processes? Anybody? No hands? No?
Knowingly.
Knowing, there's the key word here. Oh, I'm just going to upgrade Perl. There's no big deal about that. So at Booking, we were running on 5.8.5 for the longest time. Ancient Perl. And the reason why was because of this damn module right here. Well, there were other reasons, but primarily it was this damn module right here.
Which builds back to 5.0.4, but I don't disagree with all the reasons you're going to give.
Okay.
So the historical philosophy was you can upgrade it on your older Perl.
Yeah.
But I know that it breaks things. I know another company where an upgrade is storable, which then attempts to roll. An upgrade of everything, upgrade is storable, and they roll back, and they have data loss.
Yeah. Okay, so
I know what
there you go. Yeah. So this gentleman here knows everything about it.
No, well that might be true. But yeah, given that I'm familiar with its code.
Yes. So the thing is, in our environment, we have a number of different server roles that do different things, and we were using storable to communicate back and forth. So it made it very difficult to, well, we would have to bring down the entire system to then upgrade Perl to then make sure storable is upgraded, yada, yada, yada. We wanted to avoid that. The other idea that we had was basically using data dumper. Why not? It spits out something that can be read in on another process. You can eval it. Yeah. So have you ever evaled random stuff from the internet? Don't.
All the time. It's called sleep band.
Oh, sir. That is uncalled for. And then, of course, for the longest time, we were using JSON XS. It was speedy enough. It kind of fit everywhere. We could then talk to web browsers and crap with it. But it has its own problems. You know, maybe the author. Maybe it has to do with UTF-8-ness of it too. So we were ending up with like double encoded strings and things like that. It was really kind of a pain to deal with JSON XS and UTF-8 data.
And binary data, which should not be UTF-8.
Should not be UTF-8, but it would. Message pack. So we took a look at message pack, and we were very impressed with the size of the data that was being transferred and how things were encoded. Damien can answer all of your questions about that. He was one of the primary authors of Serial. Me, I'm just along for the ride. But message pack basically gives you very teeny tiny messages, and we wanted to duplicate that. We liked the idea of encoding our format in such a way that it was very efficient and compact. And then we also, no, don't do it again! Why? Why? This is terrible. This is the worst presenting software ever. Amy, why did you convince me this was a good idea?
Why did you use it? It's my engine.
I know, right? That should teach me a lesson. It should teach me a lesson, shouldn't it? So the last aspect is thrift. Who here has used thrift for anything? Well, you don't count. You're part of a... You don't count either. Who here not at Booking has used thrift?
I used it outside of Booking.
Okay, well then that's fair.
Yeah, middle.
Oh, middle finger. Where's the camera where I can show you being an asshole to me? Okay. If you've ever used thrift in Perl, you'll realize how incredibly slow it is, because the code that it generates is terrible. It has methods for, like, let's read a byte. And if you've ever done anything that's required performance in Perl, you know that subroutines and calling vast numbers of subroutines is very poor practice. And thrift apparently didn't get that message. I don't know. Plus, the whole schema thing is kind of required, and we didn't really want that. The primary source of our data is schemaless data. We didn't want to hamper our velocity by worrying about schema changes. So thrift was kind of out of the picture for us.
Apparently it's speedy in Python, or so I've heard.
Sure, and that's probably because their method calls aren't nearly as expensive as ours. Honestly, I don't know. It could be they generate better Python code. I have wanted to get a hold of the thrift module by its balls and make it do the right thing. I just have better things to do with my time. So why Serial? So there's three things on why you should choose Serial for your stuff. One, correctness. Two, compactness. And three, celerity. You see what I did there? It's alliteration. I thought it was being clever. It's not really alliteration. It's what consonant? They all start with C.
That's alliteration.
It is alliteration. Okay, it is.
It is still the same sound.
Yeah, that's what I thought too. Anyways, for those of you in the audience who don't know what celerity means, and you're not looking it up on your phone right now, it means speed, fast. If you want to be celeritas, that's not a word either. So let's talk a little bit about correctness on what Serial does right. One, it does the right thing with references. In fact, references are kind of a top-level thing in Serial. To be able to have references, like array of references versus hash references, etc.
Code references.
No. Because why are you trying to serialize code to send it across the wire? What's wrong with you?
He was looking at what wasn't implemented.
I know, yeah. So globs and code references and things
dual
like
vars.
and dual vars, because dual vars were ever a good idea. Duh.
Well,
And
I believe
formats.
the official quote is, we don't do dual bars. Why? Because fuck you, dual bars.
Ah, there you go. Fantastic.
You can make triple for it.
Serial also supports weak references. This means that you can actually pass in cyclical data structures to Serial, and it will do the right thing because it says, hey, look, this is a weak reference. So it matters for languages that do reference counting, like Perl. Other implementations in other languages for Serial, by the way, we do have that, can ignore weak references altogether if they so choose. It's part of the spec. We also support aliases, essentially C-level pointers. We can just basically have tags that say, hey, this is an alias. Objects, we can actually serialize objects with the proper class name, and the semantics are such that it's well defined that you could have the same class name in 2 different processes and reconstitute the object accordingly. Even cross-language if you want to get crazy. It is certainly feasible to do. And we'll take a look at what the serial output looks like to kind of show you what I mean by objects. We also support regular expression objects. They're definitely a top-level feature that we make use of, sending regular expression objects through as well.
Those are not cross-language portable.
Right. So the regular expression that's sent through is obviously still going to be Perl, because that's what you're using it for. So you can probably get pretty far if you stick to like PCRE, like level regular expressions, if you're sending it cross-language. But we haven't had a need to do that yet. So let's talk a little bit about compactness. So some of the things that Serial does with its particular tag structure is that short strings are encoded in such a way that they fit into a short binary tag, and the space constraint on that is such that they have to fit in do you know off the top of your head?
String ranks?
Yeah.
So it's a rate. No, it's
a short binary.
16, binary 16,
Yeah, something like that. So basically, in particular lengths of strings, like we can basically store those very compactly. Same thing with small integers. Damn it!
You must be hitting another key.
It's something with my space bar being stuck. So short integers. So if you happen to have an integer that fits into, I don't know, 16 bits, or 4 bits, I mean, we basically encode it in a single byte. So that the tag that identifies this as a short integer and the value itself, we make use of the individual bits to encode it. This saves a lot of space when you think about it. Why would I take, a full 4 bytes to, represent something that only takes up a nibble? So all of that kind of falls into Serial's domain as well. Hold on, I'm going to do this dance one more time. And how can I skip ahead to a particular slide in, 10? No, that doesn't mean anything.
That works previous.
Just change your command line.
I am going to have to change the command line.
Or put a space in the paste buffer and use Command V.
I should do that too. Okay, small integers and then reused elements. So, for example, hashes. If you have like an array of hashes that all have the same hash keys, then it just makes sense to not use the same strings over and over and over and over again. Instead, those are encoded as, I believe, copy tags that reference a particular offset into the document in which you can find this information. And we'll take a look at that. And of course, optional compression. We have Snappy compression built in. Snappy is a compression algorithm from Google. And you can basically encode the body of the document of your serial document using Snappy, and it's actually pretty fast, and it saves a good chunk of space as well. So now let's talk a little bit about speed. Let's talk about encoder performance. So I think this slide speaks for itself. This is actually from the GitHub wiki for Serial, basically showing the encoder performance snapshot at a particular time of basically data dumper no indent, message pack, not quite, data dumper light, DDL, there's a description. JSON XS storable, serial snappy, serial func, and then serial without any compression at all. And it's pretty pronounced on how fast the encoder can be with serial.
Serial func is the functional interface. which has to do a bunch of initialization every single time. The serial one is just the OO interface that sort of, you do the initialization once and then you can just
so you know modules that give you the option of doing a functional versus object-oriented interface, and you say, oh, I'm going to do the functional interface because objects are slow. That shows you it's not. Well, in this one particular case. So, and you can see in this particular one, this is encoder performance for like an array of small hashes with relations. Let's also take a look at like decoder performance as well. Serial just like stomps on things. Look at the size differences too. Both between storable and serial, and then of course with Snappy enabled. And of course JSON is just horribly verbose, so the sizes end up being really large. By the way, you can actually run all of these benchmarks yourself. There is a benchmark script in the repository, in the GitHub repository, that you can execute, and it will, if you don't believe these numbers, you're welcome to duplicate our work and basically run them yourself. Let's see here, array of small objects with relations. So you can see that trying to do like eval with data dumper and storable and whatever horribleness is going on there. And then of course you can, where was that one graph? So here's the startup times too. Like if you wanted to do just an empty hash, you can basically take a look and see that the startup time for Serial is not quite as good as MessagePack and JSON-XS. Just in the matter of decoding like a single like empty hash reference. And then of course the byte sizes too. MessagePack is going to beat it hands down because they don't have a header. Yeah, there's no header. And then of course the encoder performance as well. JSON-XS is going to beat us. So it really depends on what your data structures are. The same benchmark script also has like an example, like it's very obvious on what data structure is being generated, so that you can see, would this fit your particular use case? I know in our case it does, which is why we use it, but it may or may not be the best for everyone. Large data structures, for example, we perform very well on, even on encoding on the sizes. This is important here. We actually beat out MessagePack in size, just ever so slightly. And then of course you get all the cool things that Serial gives you that MessagePack doesn't, such as cyclical data structures and blessed objects, etc., etc., etc. Okay, let's see here. I think that was all I had on Celerity. Now let's talk about the protocol and the specification a little bit. So the basics of the protocol are such that you have a magic string at the front that is equals SRL. It encodes to a 32-bit integer that has a magic value to it, and we'll take a look at that in a second. And then header information that tells you the version of Serial that this document is encoded. Some optional fields that in version 2 will include, you can pass in metadata to be an uncompressed Serial document itself. This allows you to do things like have routing information or source information or anything related to the document, so that you don't have to basically uncompress and then parse or decode the entire document just to find out what it is and where it goes. So that was the big improvement in version 2 that I don't know what we're waiting on. I think it's Eve's paranoia.
Yeah, I think Eve wants to check out the version 2 spec, but I think Stefan's basically done the work, and it's on a branch in the GitHub repo.
Right.
But I think we're going to use it for the event writing.
Yeah.
Stuff.
So
but
for
I think we're already basically using it.
Right.
So.
And then of course, see, all I did was, anyways, it doesn't matter. Let's take.
Can you do less star? Will that help?
It doesn't matter, because now we're going to have a live demonstration. What could possibly go wrong? So first things first, let's use Serial. The serial module itself includes a use for like serial decoder and serial encoder. But really and truly, you want to upgrade those modules separately, and you want to do the decoder first. And in fact, when we do rollout, when we do deployments, and when we do upgrades to Serial itself, the decoder will be updated first. Then we will wait probably a good week before we then update the encoder to CPAN. While I know everyone in here is very careful about their CPAN upgrades, we're going to protect the less fortunate that just do a CPAN M and pipe and a bunch of stuff that's, needs to be upgraded. And then we're going to use another favorite module of mine, which unfortunately is another AMI module, because I'm lazy. So let's just take a look at what a serial document looks like. And I'll just use the function interface, which we've already discussed is terribly slow. But it doesn't really matter for a live demonstration. Encode serial, and let's feed it a hash reference, something dumb like so, and bam. Okay, so what you're looking at is the encoded output of this particular hash reference that has one key of foo with a value of 1, and you obviously aren't going to see all of the bits and bytes in there because they don't print. So, given that, what does that look like if we were to put that into a file? And then we'll just dump this into temp, foo, like so. IO all is fantastic, by the way, for doing simple things like this. And that's the pod. So one of the things that was very important to debugging the Serial project was having a pure Perl implementation. Stefan Mueller calls it the hobo decoder because it really is just some terrible hacky code. And he would be aghast if I told you to go and look at it and said that it was his code. So just keep that in mind when you're browsing through the repository. Let's see here. That is in Serial, Perl, author tools, or what is it, shared author tools. And we'll just cat temp foo into Perl hobo decoder, and then we see the magic. So basically this is giving you a readout of all of the byte values, and you can actually see what gets printed. This is what you saw in the REPL. Total length, what version it is, it has an empty header. Here is the hashref tag with the key associated with it. The key itself is a tag that contains a short binary string of foo, and the value of it is, this is another tag for a positive integer that fits within 4 bits, which is a 1. So what does that look like if we want to, I don't know, let's make that number bigger. Let's say, how about 100? 100 doesn't fit in 4 bits. So let's take a look at that. Ah, now it's turned into a varent. Who here is familiar with varents, or varent 128 is also, okay, good. So we make use of varents in a lot of cases inside of Serial. So that's essentially how we're going to represent those numbers up to a certain point. And let's see how it breaks, right? So let's, how about that much? What does that get translated to? Still a varent. How about...
You gotta break 64-bit.
Here, how about that? All right, so 64-bit. That should do it. Nope, turns it into a double.
Perl.
Yeah, Perl. And then there's also a long double tag in there as well to even encode even further. Any other examples that you'd like to see? Yes?
May I ask you to put 1 in quotes, like a string?
It will be a string.
Well, you put
Like-
1,
Yeah?
integer, but
Yeah?
put it in quotes in Perl.
Okay, sure. Yeah, so we can do that.
No. Like a value.
Okay. Hash key 1. So here's this magic that is delightful. Take a look at that. That is a string.
Good.
Exactly as it should be. So this is another problem that we had with JSON XS was the ambiguity between integers and strings. So you have to do kind of dumb tricks like, oh, I don't know, let's divide by 0.0 or something, or plus 0.1, or I don't know. There's a bunch of different tricks that you have to do to make it pick the right value. So like if it's a NVPV, it should pick one or the other, but then it chooses wrong for some reason. I don't know. But we can also see that it supports things like regular expressions. So we can do a like a QR, something dumb like this with, let's say a G. No, not G. What is it? How do you modifier on top of it? Yeah, let's just do I. And then take a look at that. And so this is the encoding of the regular expression object. So you can see that the class itself is readiness, which if you want to do any type of extending, that is what you would use anyways. And then of course short binary, which is just a string of what your regular expression is, and then whatever modifier. So it actually keeps track of the modifiers so that you can actually send regular expressions across the wire.
Can you make the pattern longer than 16?
Sure. Well, I can do one better because I know what you're wanting. You want to see the string and the string encoding. So let's say that we want to look for foo with let's see here 20 AC like so, and we'll put a star at the end of that. That should do what I think it's going to do. Right. Well, that isn't what I intended. That should be a, whatever, I need to put it in quotes. But you can see that it's converted it to an str UTF-8, and it actually keeps track of valid UTF-8 data so that you don't have to worry about, you don't have to worry about encoding or decoding via the UTF-8 module or the encode module. You can just assume that it's valid UTF-8 on the decoder side. So that's part of those really cool things. Any other examples that you would like to see that cases in which your chosen serializer has failed and that Serial may excel?
Formats.
Who uses formats anymore?
I think for the same reason that dual vars were a no-go.
Yes, exactly.
But, Ryan, you can create a format reference as a 5.8, I can't remember what. You can't use a format reference for anything apart from making objects out of. You use a key for an inside-out object. What?
You could stick it into a globe to effectively rename the
Nicholas, one of the use cases is that I can check if the glob exists too. And that's what I started using Perl Core for about 15 years ago, because nobody knew how to do it. I need to check if a format was defined before I can call subroutines.
That is terrible.
Yeah. What you do is also horrible, but efficient.
reference to reference to reference to integer.
Reference to reference to reference to integer. Yeah. So I should be able to do like a one with a slash 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 kind of thing, right?
Yeah, that's fine.
Like something like that?
Yeah.
Okay, let's take a look at that. Ref, 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 ref.
Yeah.
How about objects with magic?
With magic?
No magic.
No, I don't think the magic won't carry. Like if we were to use like variable magic and attach some magic to it, then you would have to basically like to parse that code and send it along with it, which is something we don't do.
Multiple references to the same hash. If you have say, an array of 2 references to the same hash.
We can totally do that.
So do like $h equals something, and then serial like
yeah,
array HH. That works fine.
foo1, and then we can go over here and we can go like so, and then we can do H, H, H. There it is. So there you go. They point to the particular reference.
Yeah. So you can see it says ref p8, and that 8 is the offset in the document, which you see then points to hash with 2 values.
Yep.
The key value.
Yep. So you can do ref p's, and then there's also copies as well. And I'm not quite sure what the semantic difference between a copy and a ref p is.
Copies are basically only used for strings. They can't be cyclical.
Okay.
So
Fair enough.
Copies are just an optimization, but are not used for cyclical data. They're just for repeated strings. They're basically format like LZ compression.
Sure.
Do you distinguish between references to the same hash and references to separate hashes that contain the same data?
Yes, we do. Because that is a pointer comparison. So basically, if the destination hash, like if the SV like has a pointer somewhere, and that is the thing that we use to determine whether or not this is like, do we emit basically the same key value, or do we duplicate I don't know what that's going to do.
Let's find out.
It's failed because you omitted the semicolon, but it's references to the same hash again, so it's going to be the same thing.
Yeah.
But if you do minor G equals brace boom.
Oh yeah.
That
would be
separate hashes.
And that would be encoded as a separate hash.
Yeah. Yeah, we can see
Can you serialize something and then put that back through the serializer? Serialize it a second time?
Say what?
Can you send serial encoded data or serial?
Yes, you can.
Yes, you can.
Serial exception. What?
Yeah, no, you can do that now. It'll come back as, it should come back as just a,
Come back to the string.
yeah, just come back as a string, and then you can then deserialize that string again.
We see the encoded version of what you just did there.
Sure.
Warnings,
No, hop over.
warnings don't matter, you've got it in the file.
Still do the same.
So look, it even copied the hash key, which was the same.
Yes, because the hash key, there's only a single instance of the hash key,
Yep.
so it noticed that the key was the same.
So
it does the same if it's an object to hash.
correct. So if I were to let's try that. So
Yeah,
like
objects do the same thing, and the class name, the same thing, will be copied as well.
yeah. So if I were to let's say bless H into foo, and then do that. Then you can see that it's an object of a class named foo, and it contains a hash that has this.
Nicholas, does it have an option to go on and encode even if it has unsupported fields? What I tried after you started giving your talk was, and it croaks.
It should.
No, there should be an option to continue and just leave out those fields.
No, I disagree. If you're trying to feed it bad data, you want it to fail fast. You don't want to get to the decoder and then what is this extra junk data that we have? So one of the things that we did in developing Serial as well, that Stefan spent a bunch of time on, was basically throwing billions upon billions of fuzzing junk data into the encoder and decoder to see where we could get rid of all the seg faults. And we've covered the majority of them.
So yeah, patch is gladly accepted. File an issue on GitHub.
Yeah. Any other questions?
We only lost this part.
Oh, okay. Good. Yes?
Will it visualize the blessed object with the return and the blessed object?
Yes. It does the bless.
It does it in two separate phases. So like the decoding and the blessing happen separately. So this avoids things like having an awkward destructor or something that does something malicious. So you can actually, it'll happen at a separate point.
Well, the other thing is I think it waits until the entire document has been decoded before doing the bless.
Yeah.
So that way if the decoding fails, it doesn't then run the destructors for all these objects that ended up not being fully instantiated.
Exactly.
Interesting.
Yes?
Is there any data consistency checks in the serialization?
Use your own CRC or
Yep.
Mac for verification. So just add whatever envelope you need.
Yeah, pretty much.
Okay.
Well, thank you.